And thanks a lot, for having me here today, and thank you for, coming this talk. So in the next 20 plus minutes, I'm gonna discuss, some recent work. Actually, was accepted by Management Science later last year. And this is going to be a joint work with Yang Lu, who is from Concordia University in Canada. And Jin Gong and Wan Jun actually are from Nanyang Technological University in Singapore. And in this project, basically, we want to apply some machine learning approach to design an index insurance for farmers to manage some weather risk. Right. So you're going to see nowadays climate changes, weather risk have been very hard words in the last couple of years. Like we have a bunch of work on sustainability, sustainable finance, and so on. So even if we stay in Hong Kong, we are facing lots of risk from weather, like climate changes. For example, we worry about a typhoon. We worry about a heavy rainstorm, which could lead to flooding, landslide, and so on in Hong Kong. So the whole economy is going to be affected a lot by this climate risk. And actually, there's a very important victim of weather risk, agriculture, which are often neglected, actually. So if you think about the climate changes, which are going to make changes in temperature, rainfalls, even carbon dioxide. And this is going to affect the product, agricultural product a lot, not only in terms of quantity, but also in terms of quality, like nutritional quality. So here I just gave you 3 examples. We have a drought here, and we also have a flooding. And we're going to see the impacts on plant diseases and so on. So in fact, actually, we're going to see that weather risk has been a major challenge for farmers over the last thousands of years in human history. This risk has always been there, and it caused lots of problems, economic problems, political and societal issues, right? So that means we have to come up with some solutions to manage this weather risk for farmers. And roughly speaking, we can classify those approaches in 2 ways. The first one is what I call a non-market-based solution, which is based on social security line network. For example, often governments provide some disaster relief programs to assist the farmers. But quite often we see that this approach is not sustainable. Sometimes government can be very weak, or they have some budget issue here. So we have to rely more on market-based solution. And the 2 common use approaches are insurance or derivatives. So insurance is very simple. Farmers are going to buy certain insurance products to manage this product loss later on. Or they can engage in derivatives markets. For example, nowadays we have lots of catastrophe bonds. But the reality is that often farmers are very tiny, so they do not actively engage in derivative markets. So nowadays, basically, insurance is a major product farmers can rely on. So let's look at this insurance product. First, just briefly look at conventional insurance. For example, if I buy a vehicle insurance, and in an unfortunate event, I have a car accident, then I'm going to file a claim from my insurance company. And the insurance company usually going to send someone to assess the loss of this vehicle accident. Look at like a salvage values of my vehicle, and then make a payoff. So that's the conventional insurance. But when we look at this agricultural insurance, actually things are more complicated. The first thing, often it's very difficult to assess the loss of production. For example, if a rice field was flooded, and because we still didn't harvest the rice yet, we couldn't figure out what's the loss of this flooding. So it's very difficult to assess product loss. And the second issue is a very classical one, moral hazard issue associated with the insurance product. In 2 senses. First, if we look at the insurance company, they worry that what if farmers do not do their best efforts to prevent agricultural product loss? And for farmers, it's also similar, because we know that the insurance companies often tend to deny insurance claim. So that's a very typical moral hazard issue. existing in conventional insurance market. So you're going to see that this kind of traditional insurance product is also face very low demand from farmers. So how to do that? There's a very clever solution, so-called index insurance. Because we know that if we look at this agricultural product loss, which are caused by climate risk, then we can look at the climate risk changes in weather conditions and write some insurance contracts based on weather conditions directly. And that's the basic idea, so-called index insurance. So the payoff for index insurance are based on some pre-specified weather conditions instead of the actual product loss. And those are pre-specified weather conditions can be measured from some stations. Like we have, some stations measuring temperature, rainfalls, and so on. So we can design the insurance contract based on those weather variables directly. A very clever idea, right? And here's a current practice. So right now we have some, index insurance which basically are written on low-dimensional weather indexes, usually are based on a single weather condition, like on temperature only, on rainfall only. And typically it's a linear contract. For example, what if temperature increased by 1 degree C, and here's the insurance payoff. So very simple idea. But unfortunately, it doesn't work very well in practice. So usually we say that the current index insurance faces a very large basis risk. So what's basis risk? That's an insurance term. Look at this graph on the left-hand side. So here we basically plot the insurance payoff against the product loss. So you see a bunch of black dots here. And very simple, if this insurance works very well, that means insurance payoff covers product loss exactly. So that means ideally we're going to see those black dots located on a 45-degree line. And if you look at this figure, obviously it's not the case. The insurance payoff is kind of like independent of this product loss. And that's what we call the basis risk in insurance literature. So that means farmers pay lots of premium, but the coverage is not good. So this insurance is not cost effective for farmers. And the second thing is if you look at the data, you're going to see this contract is too expensive. Like in Illinois, the corn insurance price is $45.5 per acre. So it's too expensive for farmers, right? The average farmers in Illinois actually has about 1,200 acres land. So it's too expensive. So obviously we see the demand for this index insurance is too low. And often government has to step in, provide lots of subsidies. So in US market, the government basically subsidizes 60% of the insurance premium. And that obviously is a public burden, right? So federal government spent more than $18 billion to subsidize this insurance. So here's our basic idea. We try to reduce the basis risk of this index insurance product. In our observation here is very simple. Look, if you think about agricultural production, this output depends on lots of different weather conditions. Not only temperature, not only rainfall, lots of weather variables. And their relationship is highly linear. So that's our starting point. So we are going to use some machine learning approach like neural network, try to capitalize this high dimension and also highly linear nature of relationship. This is going to help us build a more reasonable index insurance. And more than that, we are going to pin down this insurance premium endogenously and also estimate this insurance demand. Because the insurance company, they want to see what's the demand, like if you propose this product. All right. So I'm going to briefly sketch the main technical process here, but you're going to see very simple. It's not very complicated. So here we assume that the farmers has the initial worth of W0, and this guy faces a random product loss, Y, during the next year. The second part is the index insurance. We're going to design the index insurance which is written on p-dimensional weather conditions, not only single dimension. And this insurance is going to pay a premium, a payoff I here. And with the price, the insurance premium is pi. So for farmers, the optimization problem here is that we want to maximize the welfare of this farmer. And in economics, quite often we measure their welfare by their utility. All right, so you can just roughly interpret the U here as like utility objective value for a farmer. So the utility is going to derive based on their terminal wealth, which is the initial wealth minus product loss Y, plus insurance payoff, and minus the premium pi. So the key here is we want to design an insurance contract I here. And that's the challenging part. So essentially, we need to figure out the optimal functional form of the insurance contract. It's not a simple control variable. All right. So to skip these technical details, so in the end, we solve this optimization problem by applying neural network with a penalty method. So those are pure technical details. And next, let me just show you the empirical performance. So first, let's look at the data. We apply our approach to corn production in Illinois. And the sample period is from 1925 to 2018, almost 100 years of data. And the weather condition, weather variables actually are from Prism climate group, including 6 climate-related variables like precipitation, max and minimum temperatures, maximum and minimum vapor pressure deficit, and dew points. And we have a very high resolution. It's a 4km resolution data. So there's a huge data set. And the insurance market data is a very standard one from U.S. Department of Agriculture, National Summary of Business. So first, I'm going to show you why we want to highlight like linear patterns a lot. So this figure is going to show you, some univariate result. So here we basically plot production loss against one weather variable. Like for example, in the first panel, panel A, we plot against the minimum temperature in November. And in the second panel, we show results from minimum vapor pressure deficit in June. And the last one is precipitation in November. So from this graph, you're going to see clearly from those blue curves, the product loss is linearly moved with those weather conditions. It's not a linear pattern. Now, more than that, we can show another interesting result. So if we look at these two panels, which again is a univariate result. So panel A is a minimum vapor pressure deficit in October, and panel B is precipitation in October. If you look at these two graphs, you're going to see that product loss is kind of like independent of these two variables. But if we combine this into two-dimensional case, you're going to see completely different picture. Product loss actually depends on these two variables in a linear way. And that's exactly what we want to capture, right? If you design an index insurance with one variable only, you're going to miss this pattern clearly. So that's how our neural network is able to pick up those details. OK, so let's jump to the main results. So this table basically shows you the empirical performance of several different index insurance contracts. The first column here, what we denote as a linear one, which is the current one-dimensional index insurance, written based on one variable. And the last one is our benchmark result, which is based on neural network applying to 72 weather conditions. And here we compare lots of statistics. Like in panel A, we look at utility improvement for farmers. If you look at the first column, you're going to see linear contract improve very little, 0.5% improvement. But our contract improves farmers' utility by almost 14%. And the second part, if you look at this certainty equivalent of wealth level, again, the current contract only improve their wealth level by less than $1. But our contract actually improves farmers' wealth by almost $20. And if you look at this risk reduction, for example, look at standard deviation or value at risk, we're going to see our contract performs much, much better. So if you look at this value of risk at the 5% level, the current contract has a value of $332, but our contract has a value of $379. So you're going to see a huge improvement in terms of performance. And more than that, our contract is much more cheaper with a premium of 28.72 here. But the current contract has a price of $45.50. So our contract is much cheaper than the existing contract. And last, I'm going to show you this the basis risk from these two different insurance contracts. So the left panel, we already saw this guy before, and the right one is our neural network-based index insurance. And then you're going to see those black dots located exactly on 45-degree line. So our contract minimizes basis risk significantly. And the last part, I want to show you something also very interesting. Since we use 72 weather variables here, and then probably you want to figure out, hey, what are the important variables for corn production in Illinois, right? And here we compare two different sets of results. The first one is based on very simple linear correlations. We pick up 5 most important variables. And that's basically variables used by current index insurance contracts. And the last one, the right panel here, are the 5 most important weather variables picked up by neural network approach. Now, first thing you're going to see that those variables are completely different. So these two contracts identify completely different weather variables. Second, if you look at the variables picked up by neural network approach, then we're going to see that the last 3 variables I highlighted right here actually are weather conditions out of the growing seasons of corn in Illinois. That's kind of surprising, right? Here we look at the production loss of corn. Usually we think that weather variables during growing seasons should matter more. But here you're going to see we pick up some variables out of the growing seasons of this corn. The growing seasons of corn in Illinois usually is from May to October. And here we pick up variables from November and also December, right? So actually at that point, we were very puzzled. This is like something very strange, right? So we talked to people from agriculture side, and they gave us a very good answer. They said that the weather conditions outside the growing season are also very important because this is going to affect the soil condition for corn production later on. And also this is going to affect cover crops and so on. So that's something we find also very interesting. Neural network is able to pick up those important variables, which the current linear approach fails. Okay, so let me wrap up here. So overall, you're going to see that the weather risk obviously going to affect the economy a lot. And the focus of this project is we look at agricultural production. So we want to design an index insurance product to help farmers to manage this weather risk. And if you look at the current practice, which is based on single dimension linear contract, and we're going to see this, the current practice has a very large basis risk and faces a very low demand. So our approach here is very straightforward. We apply some machine learning approach, try to capture these linear and high dimensional patterns between product loss and weather conditions. And we show this approach is actually very effective, which reduces basis risk a lot and also improve farmers' utility a lot. So that's, I think, is a very promising application in terms of machine learning approach in insurance market. Because nowadays we work a lot on fintech, and quite often we focus on asset management side, right? You want to apply machine learning to asset management, but here we see very promising and straightforward application in insurance market, right? So next, let me spend a few more seconds sharing with you further thoughts about the machine learning. So when we talk about the machine learning, you're going to see first thing, this depends on large data set. We need big data, right? And coming back to our index insurance design problem, then what if we don't have data? For example, if you want to design the product in Africa, very likely you don't have 100 years of data, right? That's often the case. Or if you want to apply this product to China. So how to do that? Here's what we thought, what we called transfer learning. So you're going to see transfer learning is going to be very useful. For example, in this project, we also try to apply this approach. We train the model with Illinois data. And then we apply this model to other states, so-called corn-based states, like Indiana, Iowa, and also Missouri. And then we're going to see this model actually works very well, even without the data, training data from these 3 states. So that's the first thing. For places which we are lack of data, we can apply transfer learning. Now, the second issue with machine learning is complexity. We know this machine learning approach, like a neural network, is kind of like a black box, very complicated. So interpretability is always a concern, especially if you want to design a product. Customers usually going to have this complexity aversion. We don't like a complicated thing, like today's talk, right? Layman talk, because we don't like a complicated thing. Okay. So there's going to be a huge challenge, actually, if you want to propose this kind of product to the market, complexity aversion, which basically is coming from the lesser interpretability of machine learning. So here are a few thoughts here. The first thing, obviously, we need to increase model interpretability, right? So there are a couple of technical ways to handle this. And the second thing is we need to improve the literacy of farmers a bit. And the last approach, I think, is more straightforward, is public-private partnership, PPP. In the sense that we can ask the government to step in, provide some subsidies to this product. So we showed that, even governments provide 5% of subsidy to this insurance, the insurance demand going to increase a lot. Right? So at the earliest stage, I think a PPP going to be very useful, very important to promoting this product to the markets. All right, so those are 2 major issues associated with machine learning. So let me stop here. Thanks a lot for your attention.
Thank you, Chanvi. And I think we have time for some questions.
Sorry, so why are you a finance professor in HKUST? Why don't you open a business in Illinois and start selling this insurance product?
Good question. But just a quick answer to your question. Actually, now that we are having some pilot experiment in China with a leading insurance company.
I see.
Yeah.
Okay.
But we didn't experiment in Illinois, actually.
Okay.
But we are working on this pilot experiment in China with a very top insurance company.
Now let me ask you a serious question. So when we were criticizing the typical insurance product, you were saying loss of crop is very difficult to measure. But when you are selling your new product, suddenly I saw the loss of crop coming in the x-axis. How did it become easy to measure?
Okay, so here's the thing. Because we have hundreds of years of data, so in some cases, we do have a clear measure. Like, for example, during this harvesting season, it was flooded. Then we can estimate precisely. And in particular, now that we have a satellite image, right?
I see.
So there are a bunch of models. They can predict, hey, what's the crop years without the flooding, right? So right now we have historical data. But for real loss, it's still very difficult to evaluate, especially before this harvesting season. We don't know what's the actual loss, right?
Thank you.
And then that's how moral hazard kicks in. Thank you. Yeah, yeah, please.
Thank you, Professor. I want to know how to use the transfer learning in different areas and different countries because their climate and the addition is different.
That's a good question. So in terms of transfer learning, we still need to make sure those regions are quite similar. Like for example, in the slides, we applied this to Iowa, Indiana, and also Missouri, right? And those 3 states basically with the same, latitude as Illinois, what we call the corn belts, right? So you still need to find some locations with similar conditions without the historical data, but their overall climate, geographical conditions are very close. And of course, you can use other states as a starting point and then further refine your model. That's also another way to do it. Yeah, thank you.
All right, let me invite Danshin back to the stage as well. And so we have time for a final Q&A. If there are questions for either one or both of our speakers. And also if you have questions online and you want to put them in the chat. I will give it a minute for the online crowd, but I do have a question about the insurance modeling. So you've applied this to data from different states in the US. Have you tried doing it with areas that have this